Notice the title, Geometric Sequences and Series. So we just finished arithmetic sequences. The sequence is just like a list of numbers. This series is when you add them up. So today we're going to do geometric sequences. So there's definitely going to be some similarities, but they're of course not the same thing. Let's get started. Meredith is designing a mural for an outside wall of a warehouse that is being converted into the Taylor Modern Art Museum. The mural is 32 feet wide by 31 feet high. Let's pause there and write down 32 feet wide, 31 feet high. The design consists of squares in 5 different sizes that are painted black or white as shown. Once we get through this, we'll figure out throughout the day what the geometric sequence is. This will kind of get us there. So let's go with this first one. This here, this is going to be our square number 1. How big is this side? If the whole thing was 32, that's got to be
8.
half of 32. 16.
You said 8. So
Sorry, I'm just getting on the same page as you. There we go. Okay, so this side of the square is 16. That's just one side. Number of squares. So how many of those squares do we have of that size?
4.
2. 1, 2. There's 2 of those.
So the bottom 2 aren't like.
Yes.
I just see 4. So like the bottom 2 don't count.
Yeah, these squares are all different sizes. So we're only talking about the squares that are 16 by 16. And the area of that square, so if it's 16 by 16, what's 16 times 16? If you don't know, use a calculator.
256.
256. I'm going to do the next one with you, and then I'll let you continue the table. So we're working with this next square now. We're working with these guys. So the whole thing started at 32. We know that this was 16. So this is going to be 8. 8 is one of the sides. How many of those sides do we have? 4. And let's get the area of each one. So it's an 8 by 8. 800 is 64. Go ahead. You've got some more squares. Continue to fill in that table. Was that Angela or Jackson that came in? Do we know?
Jackson.
Thanks.
Hi. Sorry. We didn't want to interrupt you. I said.
Oh. Yeah. That's fine.
Thank you.
All right, go ahead and check your work up there. Do these numbers right here, if I were to write them in a line, would those be arithmetic? No, because if I were looking at what I was adding or subtracting, it would be -8, -4, and I'm not doing the same thing every time. This is not arithmetic. This is, in fact, geometric. If you can multiply by the same thing, then it's going to be a geometric sequence. So 16 times what gets me 8? A half. Is 8 times a half 4? Times a half is 2? Yes. If there's a common multiple, it's geometric. Now you might think, oh, it's actually dividing by 2. We kind of want to think of it as multiplying, so that it's just a fraction, 1/2. Go ahead and below this first column, put R equals a half. R stands for, it's going to be on the next page, common ratio. We used to talk D, common difference, which you're adding the same thing or you add a negative. Now we're multiplying by the same thing. Let's look at our second list of numbers. 2, 4, 8, 16, 32. Are we multiplying by the same thing to get the next term? Yeah, we're multiplying times 2, times 2, times 2, times 2. So below the second column, put R equals 2. Now the next one, 256 to 64. You might think, I don't really know what I need to multiply to get that. 256 times what gets me 64? Well, the easiest way to get that variable or that unknown is to, instead of doing it this way, think of division. So 64 divided by 256 is, what do you get, Charlie? 0.25. I shouldn't write it until I've checked it for all of them. 0.25 is the same as a fourth. If I take 64 and multiply it by a fourth, will I get 16? Yeah. Then we get smaller numbers that we can recognize. 16 times a fourth is 4. 4 times a fourth is 1. Don't put the common ratio until you know it works for all of them. Otherwise, it wouldn't necessarily work. Before we flip the page, off to this side in the margin, let's put R equals. We're going to write a generic formula for how to get R, the common ratio. Let's look at this second column. Let's say I'm at 8 and 16. If I take 8 divided by 16, will I get my common ratio of 2? Don't have to do it in the opposite order. You have to take a term divided by the term before it. So let's write a sub n. We want to divide any term by the term before it. So how do I write the term before the nth term? And yeah, term before. So a sub n minus 1. That's not something you'll put on your note card, but it's something you might need to know. If I give you a list of terms, like we did up there, 256, 64, 16, 4, 1. To find the ratio, you can pick any term you want, divided by the term before it, and that will get you your common ratio. Go ahead and flip the page. We've kind of gone through a lot, so we can go down to the highlighted words there where it says a geometric sequence. A geometric sequence is a sequence in which the ratio, the fraction, of consecutive terms is constant. The constant is called the common ratio and is denoted by R. You don't need to do anything with this, just make sure you know what constitutes a geometric sequence as opposed to an arithmetic sequence. Let's write a recursive formula. This is all the way at number 9. It says, use the expression from item 4. You don't really need that necessarily. Use the expression from item 4 to write the recursive formula. So I had this, what we had before, R equals A sub n over A sub n minus 1. If I wanted to solve this for A sub n, I wanted to write a formula for the nth term. Well, if it's being divided, I would multiply both sides by A sub n minus 1. This is a recursive formula. The nth term, so like the 50th term, would be the term before it, like the 49th term. All you have to do is multiply that by R. Put this somewhere maybe on number 9 because that's where it asks for it. Label it geometric and recursive. Do we generally like recursive formulas? No, because you have to know the term before it. So this one is not going to be a main part of any quiz or test. Your recursive formula for arithmetic, you don't have to recopy it, was any term would be the term before it, and we added the difference to it. Now that we're doing geometric, we take the term before it, and we multiply it by whatever that common ratio is. We will today create a better formula. What do we call the better kind? Explicit. Yes, we'll create an explicit formula by what's on the next page, number 10. We haven't. Number 10. For the geometric sequence that we just talked about, or a similar one, 4, 8, 16, 32, 64, dot, 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 going on forever. Identify A sub 1. First term, 4. Common ratio. You can tell by looking from 4 to the next term, you're multiplying by 2. That works all the way through. Now let's talk about how we would get the second term. To get the second term, we would take our first term, 4. We would multiply it by that common ratio. How many times would I multiply that common ratio to get just the next term? 1 time. So you're just going to say, we're going to multiply it by 2 to the first, or just 1 time. 2 to the first is 2 times 4 is 8. To get the third term, I would start with the first term, and I would multiply by 2 to get the second term. I'd multiply by 2 again to get the third term, so I've multiplied by 2 times. For the fourth term, I would have the original term. I'd multiply by 2 to get the second, multiply by 2 again to get the third, multiply by 2 again to get the fourth, so I've multiplied by that ratio now 3 times. You don't really have to fill these in. Are you noticing a pattern? Complete the rest of this. Be careful because it jumps from 6 to 10. Allie, what number did you put down here for this 10th one? Very good. we've noticed it's going to be one less because you don't multiply by the ratio to get the first term, just every term after that. Off to the side, let's see if we can write an explicit formula. This will go on your note card when we're done. We'll go on the other side of the note card. Arithmetic was the front side. Geometric will be the back. We'll get to that in a second. This is the good kind, the explicit formula, because I am able to find the 10th term without knowing the 9th. All I have to know is the first term, the ratio, and what number you want me to find. Any ideas on what I'm going to start with in my formula? Where would I always start? A sub 1. They started with 4, which represents your first term. Then what? Times R. Okay, keep going, Tyler. Times R what?
Yes. A sub n. Minus 1.
You're on the right track.
R to the n.
Yeah, to the power of, and then you were right, n minus 1. Try not to say a sub n, just n. Yep. So your first term, ours was 4, times your ratio 2, and you're going to do that n minus 1 times. If you want, you can label this explicit. This is the one you're going to use. Are we all pretty comfortable with finding or typing this in our calculator? Let's make sure we can do that. If you're not comfortable, haven't done this much before, type in 4 times 2 to the 9th power. Is this the same as 8 to the 9th power? What do we think? No, don't make that mistake. 8 to the 9th power is a huge number. If you look here, the 2 has the power of 9. The 4 doesn't. But by combining them together, you've just said, hey, now it does have the power of 9 and it shouldn't. They must stay separate. That's why we do order of operations. Exponents come first. So 2 to the 9th, and then we multiply. All right, grab your note card, please, if you haven't yet. I think everybody had a green one. I don't know. One side should be completely done. It should say arithmetic. Go ahead and flip it to the other side. At the top, write geometric. This is our only formula for today. We will have, I believe, one tomorrow and one the following day. So this is what you want to write. I can find any term, a sub n. A sub 1 times r to the n minus 1. Don't get sloppy. Try to make sure your n minus 1 is small. It's above the r as the exponent. All right. I got some good ones for you. Well, 12 is in your book. I'm going to come up with some other good ones. Number 12 in your book. Use your formula from item 11. That's what we actually just came up with, your explicit formula. Find the indicated term in each geometric sequence. So 12a, they're giving you a sequence. They want you to find the 16th term. We might have some larger numbers now because we're dealing with multiplication. So those numbers get big or small really fast. Not a lot of work to show. Go ahead and do B. You're finding the 9th term. Let's say your quiz asks you for the formula. Let's redo this one, and instead of finding the ninth term, let's write a formula for the nth term. So the way I write my formula is a sub 1 times the r to the n minus 1. And that's just how I leave it. There's no simplification that can happen there. It would be very wrong to multiply this times a fourth, because one has an exponent and one doesn't. So this is your formula for any term a sub n. Questions on geometric? Okay, let me give you some more difficult ones. Put this anywhere in your book or scratch paper. I will tell you this one is geometric. I'm just going to let you brainstorm with this for a minute by yourself. I want to see if you can write me a formula for a sub n. If you did come up with an answer, plug 8 in for n and see if we get that large number. Anybody get a formula that wants to share what they got? I'm still calculating. Let me give you a little more time. We don't want to do guess and check. Anybody able to tell me a good way to find R? I think some of you got it, because you do a lot of calculating. Let's think about how we did arithmetic. When we did an arithmetic sequence, we wanted to know from here to here, how much did we add? Are we adding in geometric sequences? No. For geometric sequences, we want to know how much am I multiplying. So I want to know 96 times what, gets me to that large number? I don't know. So I'm going to divide. So 98304 divided by 96 is 1024. I can recheck it. 96 times 1024 gets me to this bottom number. That's how much got multiplied. If I'm going from the third term to the eighth term, I'm going to have to multiply by r to get the fourth term, multiply by r to get the fifth term, multiply by r to get the sixth term, multiply by r to get the seventh term, multiply by r to get to the eighth term. What's a better way of saying r times r times r times r times r? R to the fifth. From the third to the eighth term, I've multiplied by r times r times 5 times. So r to the fifth creates this much multiplication. Let's write this down. R to the fifth equals 1024. Are we with me so far? Okay. See what was multiplied. See how many times you had to multiply r. Now, are we going to do the square root? It doesn't make any sense. We're going to do the fifth root. Your calculator doesn't have a fifth root button, so you kind of have to create it yourself. So to do the fifth root, your calculator, if you have a graphing one like mine, you'll type the 5 first because we want the fifth root. Go to math, and that fifth choice down says star root, meaning you can put any number in there you want. Type the 5 first, hit math, and go down to your fifth choice where it says, star root, meaning that number is your index. And then you can type in fifth root of 1024 is 4. I'll walk around. Let me know if you need help. If you don't have a graphing calculator, there's probably still going to be a star root button. Anybody need help? I cannot answer calculator questions on assessments. Okay, so let's look at how far we are. We have the r term. I don't have the first term yet, but I know r is 4. I don't fill in n, so we're good there. I just need the first term now. Kind of like we did before. If I want the first term, I'm going to have to do r 2 times. R times r. If my r is 4, r times r is going to be 16. Am I going to add 16, subtract 16, multiply, or divide 16? Divide, because to go here we go forward, which is multiply. So to go backwards, we need to divide. 96 divided by 16 is 6. 6 times 4 to the n minus 1. That's your formula. I told you on the quiz you guys just took to check your work. I want everybody to check your work. Plug 8 into the equation you just wrote and see if it's right. That would have saved a couple people some points on the quiz because you created arithmetic equations, but some had mistakes and you could have caught your own mistakes. We'll see. Alrighty, here is your homework.